So we go from mesoscale or local winds to the planetary scale, the macro scale. So we can actually cut the world, chop it up along lines of latitude into 3 sections in each hemisphere. So we call this the 3-cell model, but it's 3 cells in each hemisphere, which by my book, that's 6 cells. Okay, so we have these 3 cells. I'm going to kind of talk you through it. This is closest to the equator. So from the equator to 30 degrees latitude, now this is approximate in either hemisphere, we have the Hadley cell. Then if you go from 30 to 60 degrees, we have the Ferrel cells, and then from 60 to 90 degrees, we have the polar cell. Now that's just very rough, and these kind of boundaries wander throughout the year, and we'll talk about that a little bit. So here is my 3/6 cell model. So of course the equator is 0. Okay, this would be about 30. Okay, and then this is about 60. So again, very crude. Now let's see. Yes, all right. So in general, the air flows, how do I want to say this? See these boundaries? Like if I call this cell 1, which is the Hadley, 2 the Ferrel, 3 the polar, along these boundaries actually air flows up and down, okay? And I'll just kind of put up and down because we'll talk about that in minutes. Let me go ahead and say which direction it is. You can see here it's flowing down, here it's flowing actually up, and here it's flowing up, okay? So it goes up vertically, okay? Then along these, in general, this is very general, think of air going horizontal. Now it doesn't flow like north and south like this, but it kind of flows, well, I'll show you. At the Hadley, it flows actually from the east to the west, okay? And for us in the Ferrel cell, it goes from the west to the east, and up the last cell, it goes from the east back to the west again. So just in general. Let's see, what else I want to say. So these cells are generally confined to the troposphere. Remember we said above the troposphere is the stratosphere and the mesosphere and the thermosphere. So think of these as occurring within the troposphere. The one last thing I want to mention, because it's carried on onto the next slide, if I were to ask most people, they'd say, wow, the equator's hot. And along those lines, our cells kind of start out with that in mind. So hot air, one of the things that you know about hot air is it's generally buoyant. Hot air rises. And so that actually creates a feature we call the intertropical convergence zone. It's kind of the hot spot. Okay, now the intertropical convergence zone, although you say it's right there at the equator, it actually kind of wanders throughout the year, and you can kind of see it wandering. It's not right at the equator. It also depends upon where the land is, because it has to do with, I kind of mentioned, the water's stubborn to heat up and cool down. So it's kind of where the large bodies of water are. It kind of wanders around. But the intertropical convergence zone, think of it as, okay, here it is in July, and here it is in January. But think of it, if we go this way, we have the Hadley cell for the north hemisphere, and if we go this way, we have the south Hadley cell. So kind of think of it like that. Okay, we'll be talking more about the Hadley cell coming up.